So internet sucks. Ah, there we go. Whew. Yeah, what is happening there? It did not want to start with my recording. Okay. So like I said, right, we are continuing 2.4 and hopefully we're finishing 2.4 today. And we talked about last time, we looked up online, what was the average height for a male in the United States, right? And we found out the average height for a male in the United States was 5 feet 9 inches. Wait, yeah, 5'9", right? That's this guy right here. So using the empirical rule, if we know that average height or male heights is distributed normally, right? Like makes that bell-shaped curve. If I took 100 people and lined them up by their height, and if someone was already 5'9" and I marked it down, and I found someone else that was 5'9", I'd make them stand in a line, right? So I'd make them stand in a line going like so, and same thing for 5'10", 5'11", and 6 feet. If they lined up with someone else who was the same height, they'd line up behind them, right? And if we get everybody to line up like this, it makes almost like this bell-shaped curve. See that? And then what I'm saying is, if you do that and you go and you know what the standard deviation is, and I just made up the standard deviation. I don't actually know if the standard deviation is 2 inches. I just put that in there just because it's easier to work with. But if you go standard deviation of 2 inches, if you go one standard deviation this way and one standard deviation this way, and you circle all the people who are standing right here, what I'm saying is that if you had 100 people, 68 of those people are going to fall within that range. 68 of those people are going to be between 5'7" and 5'11". That should be 5'11", right? 6 feet is this one. So that's what I'm saying here. If you know what the standard deviation is, it's a strong tool that helps you not only help you figure out, you know, what's kind of close, what's kind of far, and what's hella far, but it also helps you guess a number of how many people should be in this range. Now, is it going to be exactly 68 out of 100? No, it's a 68% chance is what the idea is, right? But that's all the empirical rule is. That's what the beauty of that number is, by the way. And I wish I could show you guys how that's calculated, the whole 68, 95, and 99.7, but it's like a really ridiculous equation, and it's like a combination of statistic equations and a little bit of calculus, and it's not worth going into. But that's the idea, right? That's the idea. If you know what the standard deviation is and you go exactly one of those standard deviations above and exactly one of those standard deviations below, right, you'll get 68% of the population, right? And then you can go even further with this. If the standard deviation is 2 inches and you go 2 standard deviations out, so 5'9" plus 2 is 5'11". Add 2 more inches, and you go out here to 6 feet, 6 foot 1 inch. I think I'm doing the math wrong, right? And you also go 2 inches below this one, which would be 5'5" if you go 2 standard deviations below, and you incorporate all the people here from 5'5" all the way up to 6'1". I'm saying that that captures 95 out of 100 people, right? So if you have 100 people lined up this way, 95 of them are going to be between 5'5" and 6'1". And I hope that kind of makes sense. That kind of logically makes sense, right? If we were actually in the classroom and I took all the guys in our classroom and we lined each one up, right? I'd say like the majority of the male students at Lawndale would be between 5'5" and 6'1", right? That's almost everybody. Right? That's only 95%, but it's a good chunk of them, right? I don't know if you guys can remember back to your classes, but do you remember that? If you did have tall people, or if you did have really short people, there wasn't that many of them, right? There wasn't that many of them. There was maybe 1 or 2 people who were 6'3" or 6'4", and they might have been on the basketball team. And you might have had a few guys that were below 5'5". There could have been a couple guys that were like 5'4" or 5'3", but they didn't make the majority of it, right? So if I go 2 standard deviations, that covers 95% of them. So 95% of the people that you know of should be between this range, right? And of course, there are outliers, and those outliers we'll talk about later. But again, that's all the beauty of, that's all the beauty. That's all the purpose of these numbers right here is they help you estimate those values. If you know what the mean is and you know what the standard deviation is, you can calculate a percentage of the people who fall between these ranges, right? Between these ranges. And if you go one more standard deviation, that's when you go to 3 standard deviations out, right? If you go one more out, so instead of 6'1", you're going to go out to like 6'3", right? 6'3" inches, and over here, instead of 5'5", you're going to go down to 5'3". I'm saying if you encapsulate all of these people from here to here, which is 3 standard deviations to the right and 3 standard deviations to the left, you're getting 99.7% of your data, right? So if you have 100 people, 99 of them are going to be between 5'3" and 6'5", right? The wider I keep making this out, right, it kind of makes sense, right? The more data I'm gathering, but it's not a random number, right? It's based off of the standard deviation, right? If you know what the standard deviation is, you don't have to go out like, well, if I go out 10 inches this way and 10 inches that way, that will capture everybody. But that's just some random number. If you take into account the actual standard deviation and you do this, you can almost guarantee that like this is the norm. This is what you should be between, which is 5'5" and 6'1", right? And that will cover like 95% of them. And that's how we usually measure it. We're looking at about 95% of the population to say like majority is here. And if you're outside those 5%, then you're kind of like unique, right? You're kind of unique. You're not like super special. You're just kind of unique. And if you go way beyond that and you go out to here where the remaining 0.3% is, this is why I keep telling you, we look at that as hella far. You're hella like, that's what I mean. If 5'9" is the average and this is it, and 3 standard deviations is 6'5", and you saw someone who was 6'6" or 6'7", would you not look at that person and say, dang, you are hella tall, right? And that's how that applies to this right here. Your 3 standard deviations out there, you're hella far from the mean. Same thing, and this would be cruel. Don't say this to a person, but if you saw someone who was like 5'2", right? Don't look at them and say, man, you're hella short. I mean, it's true, but that's rude. Don't actually. I don't know why that's rude though. Why is it okay to go up to someone who's tall and tell them they're hella tall, but you go to someone who's really short and you tell them they're hella short? That's rude, Nakni. Why would that be rude? But yet it's not rude to say it to a tall person. I guess it's rude to say it to a tall person as well. It's just, yeah, don't actually go and say that to these people. You have to be honest and tell them that they hella No, Calvin, don't do that. Don't do that. That's rude. Don't. That's mean. Wait, though, honestly, though, why is that the case? Is it not considered rude to go to a tall person and say that to a tall person? Is that just like, is that okay? That shouldn't be okay, right? I know it's not okay to say that to a short person. It shouldn't be okay to say that to a tall person. It is rude. Yeah. I know more so that it's rude to it's even worse. It's even more rude to girls for some reason. I don't know why, but for some reason it's like girls aren't supposed to be tall. And I don't know where that came from. That became like the social norm, right? People just still do it. Yeah. For guys, yeah, it would be kind of rude, right? You go up to some random guy. That's not equality in my eyes. Yeah. I'm sorry, I got distracted there. That's a random. Sorry. What was I talking about? The empirical rule, right? And I got distracted by height. Oh my gosh. But yeah. Let me focus back over here. 68%, 95, 99.7% is what we were talking about. And if you know the mean and you know the standard deviation, you can measure specific things. And I was going with height, but you could also go with like salary jobs, right? Like how much people are getting paid annually, right? If you know the average pay and the standard deviation, you can figure out, hey, man, I'm getting screwed over here, or hey, I'm within the range, but I would like to get paid a little bit more. Would it make a little bit more sense if I could ask for a raise or not? And that's the idea here. That's the idea behind the 68, 99, 95, and 99.7. If you look on here, your previous teachers might have asked you to memorize the values that are in between them, right? So you might see this 34%, this 13.5%, and this 2.35%. I'm not going to have you memorize these values. In fact, you might just want to put that table somewhere nearby just so you to have as a cheat sheet. I don't think you need to memorize them, but it is the same rule. If I was going from here to here, right, it makes sense that it's 68%. And of course, if you cut that in half of 68%, that's how they're getting this 34, right? Same thing with this part right here. If I was looking at 2 standard deviations below and 2 standard deviations above, that's 95%. But if you cut that in half, that's roughly 47.5%, right? If you cut this in half right here and you look at it from here to here, that's about 47.5%. Then how are you getting this 13.5? You're taking 47.5% and you're subtracting the 34. And this is what I mean by I don't think you should bother with memorizing these values. Just have this chart somewhere nearby, and it'll help you calculate the percentages that you need that are between this or that, right? I don't want you to memorize these values. I don't think it's worth it, but it will come to you naturally after you've done a couple of these problems. But I think the bigger deal with this problem is setting it up, right? The bigger deal with this problem is setting it up. Okay, so let's go ahead over here and let's do this problem here. You know Pear Deck today. You can just go ahead and write this into your notes. I'll give you guys the credit for today for participation today. Just to make it a little bit easier. It's a nice end of the October day, so you can just write it into your notes if you want to follow along with that. And if not, you can copy into your notes later. I mean, I'm still grading your notes, so we'll do that. Okay, so let's take a look here, right? Back with the heights. Back at it again with the heights, knock me. All right, let's see here. In a survey conducted by the National Center of Health Statistics, the sample mean height of women in the United States ages 20 to 29 was 64 inches. So looking at this data right here, I read this out and they tell me that 64 inches is the sample mean, right? It's the sample mean. So I can write that down. I found out just by reading here that the average height of women in this sample is 64 inches. 64 inches. Which, by the way, that means that the average height of females in the United States between 20 to 29 is about 5'4". 5'4". So actually, if you are 5'4", you're not considered short if you are a female. If you are 5'4", you are the average height based off of this sample, right? So if anyone tells you you're short, show them the statistic, right? Like, man, I'm not short. I'm average. And that's what it is. 64 inches. And here's the thing. How does that work with your Bell's distribution? If you see the symbol right here, that X bar, the number that goes exactly in the middle is whatever your mean is, right? So if your mean is 64 inches, then 64 is what I'm going to write right there in the middle. And that's what you guys should write as well in the middle of your notes, right? I provided this bell shape here for you just so you can have it. And I really suggest that you get that one down. All right, so let me see here. 1 second. I forgot to set this up. Okay, so let's keep going with this problem. The next thing they tell us is that it has a sample standard deviation of 2.71 inches, right? Sample standard deviation, do you guys remember the symbol for that? And if not, you got to start getting that down. But the sample standard deviation is just S, right? If it was a population standard deviation, we would use sigma with it's basically the O with a little line. So it's just S in this case, and S in this case is 2.71. 2.71 inches, though, right? So what do we do with this information? Well, with this information, we could figure out the percentage of women who are between specific heights, right? You can figure out the percentage of women who are between specific heights. And I think that's awesome because check this out. So I take my calculator out, and all I need to do to find out how far away one standard deviation is simply add and subtract my standard deviation to my mean, right? So check this out. I open up my calculator. My mean is 64, right? My mean is 64. We just found out the standard deviation is 2.71. If I add that to my mean, I get this number, 66.71. What that represents is one standard deviation, 66.71. That's one standard deviation above the mean, right? So if anyone is 5'6", right? If any female is 5'6", you're taller than the average, but you're not that much taller than the average, right? You're not that much taller, by the way. Let's write that out as 5'6". This is this one is the average. This is 5'4", right? Well, it's 5'6" and some change, right? And some change, but I'm not gonna write that down. This is estimating it, but right. So you can actually look at the statistics now and say, oh, if you're 5'6", you're only about one standard deviation away from the average, and that's not that far, right? That's not that far. And you can also go in the other direction. You can go with 64 minus the standard deviation of 2.71, which will give me 61.29. 61.29, right? And that's about 5 foot 1 inch, right, with some change as well. And what I'm saying is, if you're between 5'1" and 5'6", you're relatively close to the standard deviation, right? You're relatively close to the standard deviation. Not only that, if I had 100 women lined up by height, 68 of them should be between 5'1" and 5'6". Does that make sense, guys? Is that okay? Hopefully that kind of makes sense. If not, we'll keep doing this, by the way. And you'll see that the pattern for this isn't actually that bad. You ready for this one? To get 2 standard deviations away, right? To get 2 standard deviations away, all we have to do is take our average, 64, add 2.71 twice. Add 2.71 twice. That's what 2 standard deviations means, by the way. You're adding the standard deviation twice to your mean, right? And that tells me, that gives me 69, 69, nice, 69.42, right? 69.42, which is, by the way, 5 foot 9 inches. 5 foot 9 inches, right? Have you met a woman who's 5'9"? Come on, you gotta laugh when you see that number, right? You never met a girl who's 5'9"? That's because, considering this data, that's 2 standard deviations away. That's considered pretty tall. That's actually it's not really tall, but it is tall, right? They're 2 standard deviations away, without heels, by the way. 5'9" without heels. With heels, they'll probably be like, I don't actually know how tall heels are. Are they like, is the standard heel like 3 inches, 2 inches? It's not, yeah, right? I don't know. Anyways, right? But that's all that is. 5'9" is considered 2 standard deviations away. I don't know either, but that's what that is. And we could also go in the other direction. If we go 64 minus the standard deviation twice, right? Minus the standard deviation twice, that helps us to find 2 standard deviations below the average, right? Below the average, which is 58.58. 58.58, which is roughly, is that like 4'11", right? I think that's like about 4 foot 11 inches. Which, at the same time, I'm going to ask you: do you know many females, many women who are 4 foot 11 inches, right? Do you know many that are there? So you're telling me my mom is within 2 standard deviations? Yes, if she is between 4 feet 11 inches and 5 feet 9 inches, she's within 2 standard deviations, and she's part of this 95% of the population who are between 4 foot 11 and 5 foot 9, right? And 5 foot 9. Your height potential. Well, you never know. My mom is, how tall is my mom? My mom's like 5'2", and I'm 6 feet, right? So that, I think I got most of my height from my dad, though. My dad is 5 foot 11, so I'm like 6 feet something. My grandma was 4'10". Oh man, so she is definitely shorter than that's rude. Knock me. Don't say that. She was more than 2 standard deviations away from the average. That doesn't sound as mean, right? That doesn't sound as mean. So yeah. So that's how that works. And then you can go even further. You can go to 3 standard deviations away. You ready? You can go 64 plus 2.71 plus 2.71. That's 2 standard deviations away. And get a third one in there. Right? So 72.13. That's considered 3 standard deviations away. Let's do that one in purple. What was the number? 72.13. 72.13 inches, which is roughly, I should know this. This is going to be 72 divided by 12 is 6 feet. 6 feet and some change, right? 0.13 inches. Yeah, that sounds about right. Yeah, 6 feet and some change, right? That's tall. Yeah, so if you find a woman who is 6 feet tall, that's considered 3 standard deviations away. They are hella far from the mean. That doesn't mean that they're, I mean, yeah, they are hella tall. I just got myself to say, don't say that, not me. But yeah, they're 3 standard deviations away. They're hella far from the mean, right? And then we can go the other way as well and subtract the standard deviation 3 times as well. 2.71 minus 2.71 minus 2.71 3 times, and that gives me a standard that gives me 3 standard deviations below, which is going to give me 55.87, which is roughly, man, I'm struggling today with these numbers here. I think that's going to be 4 feet 7 inches. Oh, thank you, Carwin. Trying to do that in my head. I appreciate that. 4 feet 7 inches. And actually, I think if you go that low, I think you're considered a little person at that point, but I'm not sure. There is an actual like height cutoff to call someone a little person. Little person height. Oh yeah, 4'10". 4'10" is the cutoff for that. Hella short. Yeah, I mean, I have this on tape too. I swear, one of these days someone's gonna go back and do these videos and it's just like, not me can't say stuff like that. Well, I did. Delete all the evidence. It's okay, guys. It's okay. It's all for the sake of learning statistics, and if it's ridiculous, at least you've learned something that is ridiculous, but it helps you with it. Now, why did I calculate all these values? I just wanted to show you how we apply the mean with the standard deviation, right? It gives me all of these numbers down here in the bottom, right? But we don't care about all these numbers in the bottom. Actually, if you read the problem, it only cares about the heights who are between 64 inches and 69.42, right? That's all it cares about. And if you look here, here's 64 inches, here's 69.42 inches. And I only care about the percent of women who are between that. And the percent of women who are between that is from here to here. And like I said, you do not need to memorize these percentages. You just need to know how to calculate them. And Calvin, you're right. It is 2 standard deviations, but be careful when you're stating this. It's not 2 standard deviations away, because if you just say that, it implies that you're away below and away above. When you want to say for this one is 2 standard deviations above the mean, right? You want to go with a complete sentence and tell me it's 2 standard deviations above the mean. So it includes the mean all the way up to 2 standard deviations above it. So the percentage, my answer, right, is 47.5%. That's my answer for this problem, right? How did I get 47.5? You just add the percentages that you have on this chart, right? So this is telling me, oh, it's 34% plus 13.5%. That's how I'm getting my answer of 47.5%. So if they want to know how many people are between 5'4" and 5'9", almost 50%. Almost 50%. It's about 47.5% of people are between 5'4" and 5'9", right? And if your height is below 5'4" but taller than 4'11", it's the same percentage, right? If you're between 4'11" and 5'4" or 64, I should say, it's the same percentage this way as well. And that's the beauty of these bell-shaped curves, is that it's symmetrical. If you go the mean and 2 above, it's going to equal to the same percentage as the mean and 2 below, right? So yeah, I really wish we were in person right now. And I used to have my students line up by height, and we would go outside and do this, and you can actually see this most of the times, not all the times. Most of the times, though, tall people would be there would be the same amount of tall people in this class as there were as short people. Right? It would almost it would almost be symmetric on both sides. And if I had a larger class size, like if I had a class of like 100 students, and I had you guys line up on the football field, you'd actually see this in play, right? You actually see this in play. Of course, this didn't always work, because sometimes I'd have a class filled with like 7 basketball players, and I don't know how that happened, but in that class with 7 basketball players, you could imagine, right, how much my data got skewed to the right. I had a couple more taller people in there that didn't fit with the average, and that would mess up my whole bell-shaped curve. Anyways, right? That's all you're gonna do to use this empirical rule. You'll calculate these numbers down here, and then look to see what they're asking for, and tell me the percentage that's between them. right? Tell me that's the percentage that's between them. Let's try some more problems. Okay, let's try some more problems. So let's take a look here. This one, they're kind enough to draw it out, the bell-shaped curve for us again, but this time they want us to find the heights that are between 61.29 and 64 inches, right? 61.29 is over here. You guys see that? I'm gonna go ahead and copy these numbers down and bring it down to the next part below. Can I do this? Will this let me copy? All right, knock me. Let's see if this works. Copy, paste, and then let's just drag these numbers down. Yo, technology is amazing. Does it line up too? Does it line up too? It does line up too. Look at this, guys. Can you guys do that as well? So the number on the bottom don't really matter. This is just for my frame of reference. I wrote it down as 5'6" just because it's easier for me to picture the height, because I can't picture 66.71 inches. But yeah, you're right. For the question that's in hand, they don't seem to be asking it in feet. They're just asking it in by inches only. So the bottom number, yeah, it doesn't really help the problem. It just helps me as a person to visually see how tall is 66 inches, because I don't know how tall is someone who's 66 inches. But I do know how tall someone is who is 5'6" inches. But yeah, you're right, Michael. We didn't need these bottom numbers. We technically only needed these numbers. And does anyone have questions on how I got these numbers right here? Are you guys okay with how I got the 66.71? Are you okay with how I got the 69.42? Are you okay with these guys in purple and red? Does that make sense or no? Yes, no. If you have a question, now's the time to ask. How did you get these numbers in blue, red, and purple? And I'll just say it right now, even if you don't type it out. How did I get those numbers, guys? The problem originally, oh, okay, you do not want to work anymore? Hello? Close that, open that. Technology, it's so cool and at the same time, so flawed. The original problem, if you read the problem, it tells us that the sample mean is 64 inches, and that's where we got that number from. We got this number from reading the problem. And then they tell us that the sample standard deviation is 2.71, and that's how we got our S, right? Our S is our sample standard deviation. When with those two values, you can fill out any bell-shaped curve, right? As long as you know that it's normally distributed, you know that it forms this bell-shaped curve. And to get these numbers, all I had to do was to get this 66.71 was take 64 and add 2.71, which is, again, our mean and our standard deviation. They tell us that value in this problem, okay? And that's all it is. So this one adds by it, and then this one subtracts by it. I said subtract, and yet I was about to draw a plus sign, 2.71. Right, and that's how we got those numbers, okay? Once you get those numbers and you fill out all these numbers all the way across the bottom right here, remember which one represents 2 standard deviations above, which one represents 2 standard deviations below, and so on and so forth. And you'll be able to answer this question right here, which is, what is the percentage of heights that are between 61.29 and 64? Well, here's 61.29 and here's 64. So where's the chunk of the bell-shaped curve that's going to be included here? The chunk goes from here to here and here to here. So what's the answer for this problem? What's the answer for this problem? 34%. That's it. That's your answer. 34%. Again, do you need to memorize those little percentages? No, you do not. It makes your life easier if you do. But you know what else makes it easier? If you just take the notes and put them somewhere and have a copy of these percentages, right? I don't really care too much about those values being memorized. I mostly care about, do you know how I found these numbers down here, right? That's what I mostly care about. If you can figure out how to fill in those numbers, the rest of the problem is cake, right? Like I said, you're not memorizing these percentages. The only ones I really care about is you finding those numbers. If you really want to memorize some numbers though, and you want to sound impressive, memorize these basic ones of 68, 95, 99.7, 68, 95, 99.7. Even if you don't have any idea what this is many years later, I still want you to remember 68, 95, 99.7, 68, 95, 99.7. 68, 95, 99.7. 68, 95, 99.7. Sorry I repeated myself so many times, but that's just the easiest way to get you to remember it, because now whenever you think of the empirical rule, you probably should go to 68, 95, 99.7, right? Don't worry about the percentages that are in between there. Just use this as your notes somewhere on the side, and you will be able to recall that. All right. So that's it. That's the answer. 34%. So you need to fill out the chart as best you can based off of the average they give you and the standard deviation. So you get these numbers on the bottom, and then you just tell me what the percentage is for the interval that they care about. What's the answer for the interval that they care about, right? In this particular case, it's here. All right, let's go down here to the U-try, for the U-try, and I want to give you guys 2 minutes to fill out the numbers that go down here. Can you guys do that for me? I'll give you 2 minutes. Can you fill out the answer of the numbers that go down here? And if you feel like that's too easy, you can go ahead and tell me the final answer too, and tell me what is the percentage for the data that's between 1300 and 1700. All right, so let's go, 2 minutes. You're not checking in on a Pear Deck with me. This is strictly just for your notes and for your sake. Yeah, how comfortable you will be if I were to give you a quiz problem like this. Would you be able to tell me the percentage that it is between? All right, so practice now, practice now. If you don't know what to do, that's okay. Let me get you started then. Read the problem. The mean value of the land and buildings per acre for a sample is 1,500. Just by reading that off. Oh, I'll go up a little bit. Is that good enough, Michael? Yeah. Okay. So the mean in this U-try that hopefully you're trying in these 2 minutes right now, they tell us that the mean is $1,500. What's the symbol for the mean of a sample? It's not mu. This is the mean of the population. I want to write this down as X bar, right? X bar. That's my mean. If you know what I mean. My mean is 1,500. Okay? Keep reading the problem. They tell you more info. With a standard deviation of 200. I don't know if you guys can see my highlighter, but I don't know what the heck happened to my highlighter, but it likes to like become like a laser beam. Kind of neat. Anyways, I got distracted. So I have my standard deviation for this. And again, it's for the sample standard deviation, which means that I'm using S, and S in this case is $200. S in this case is $200. In about a minute, I want to double check with you guys, right? Are you able to fill out the rest of, I'm going to scroll down now, Michael. You okay? Hopefully you already got what you needed. Can you fill out the numbers that go below the curve? Based off of what I just have written there, I have a 1,500 and I have a 200. Is that enough information for you? Yes, it is. And see if you can figure out how to get those other numbers. You can do it. You got this. You ever been like randomly sleepy? I should ask that. I'm pretty sure all of you guys have been sleepy, of course, before, but like I don't know why, but like the past couple of days, I think I'm like getting like caffeine withdrawals or something because my eyes are like heavy. Yes, sir. Yeah. I don't know if I talked to you guys or was I talking to my calc class. Like for the past maybe month or so, I was like to teach class. I don't know if you guys saw it. I would have like a can of Bang, which is like the energy drink, and I would only drink like literally like less than a third of it, like maybe like a quarter of it. I take sips here and there, but I would never drink more than a third of it, just because it would like so much caffeine, and my body was like, ah, yay, caffeine. And I was getting tired of feeling the crash of it, so I was like, I'm gonna stop drinking Bang. And I think my body's like getting withdrawals from it because I'm like super. I feel like I'm still awake, I'm still conscious, but I'm tired. I don't know. Here's an idea. Let's just nap instead of doing 2.5. I mean, you guys always can. There's nothing I can't reach through this camera and say, hey, wake up, right? We're not in the classroom, right? I'm not here to like, I'm not there to mess with you if you do take a nap, Isabella. You always could take a nap, and then you could just watch the videos, then later catch up. I don't think I can take a nap though, because then I'd just have me recorded as me like, what are we doing in class? Not me taking a nap. It's like, no, just turn off the camera. But then why did class end so much earlier than normal? Maybe I'm just thinking about this too much. Caffeine is bad and addictive. I agree. I think that's why I feel kind of bleh. And at the same time, I want to just drink another can just so I can feel re-energized. All right, guys. Let's double check if you guys got the right answers for this one, right? Let's see if you know where these numbers go. And I hope you guys can see the symbol. If you zoom in closely, the symbol that's exactly in the middle is this X with a bar by itself. So when I ask you to fill out these normal curves, I hope you understand the number that goes exactly in the middle is the X bar number, which again is just the mean. See that? The mean goes in the middle, right? If it's a normally distributed curve, that means the mean, the median, the mode are all exactly the same, which is this middle number right here, which is 1500. You see that? 1500. To fill out the rest of these guys, we simply use our calculator and combine it with the standard deviation. Okay, so if I take a look here, if I go at 1500 and I add one standard deviation, that 1700 is telling me that that's this number right here is 1700. And if I take that and I subtract it from the mean, that's still one standard deviation, but it's one standard deviation below. It's one standard deviation below, which is down here, which is 1300. Now, if you read the problem, you realize you could just stop here, because 1300 to 1700 is what's in question, and that's the percentage from here to here, right? Which is exactly what's my answer, 68%. Now, if you're doing this on a test, right? If you're doing this on a test and you don't remember the percentages, at least fill out all the numbers on the normal curve. I will give you a good chunk of the points if you do that for me. And how hard is it to get the rest of these numbers on the bottom of your curve? I hope you realize it's not that hard. You just take your average and you add your standard deviation repeatedly, right? You add it one time, that gives you the first standard deviation above. You add it 2 times, and that gives you 2 standard deviations above, right? So plus 200 again, that's going to give me, I did not need a calculator for that, but okay, 1900 right here. And if I go 200 below this one, this will be 1100 down here. And for the last one, this should be 2100, and this one right here will be 900. And that's it. That's the biggest thing about these normal curves. If you can just tell me what those values are, you've done like more than half of the problem. Not just half of the problem. I'm telling you, more than half of the problem. If this was a 5-point problem and I asked you to tell me, hey, what's the percentage that's between 1300 and 1700? And you didn't get the 68%, but you got all these numbers down here, I'd give you 4 out of 5 points. It means that you understood the mean is the number that goes in the middle, and that the standard deviation is what you use as a tool to measure how close and how far you are. And that's the bigger deal I want to get from you guys. If you can get that for me, I'm giving you 4 out of 5. And that's a B on a problem. And that's without you telling me the final answer, right? So if you can get that for me, you got a B. If you get the last part, which is the percentage, that will give you the last point for a 5 out of 5, right? That's how that works for these bell-shaped curves. That's all you got to do for me. You just got to tell me, oh, it's from here to here, bam, this percentage, okay? Hopefully that's okay. Hopefully that's okay. Hopefully that makes sense. Right? So that's that. Hopefully that's okay. Do you feel okay? Do you feel confident? I'm gonna put a poll up for you guys. How do you feel about this thing? How do you feel about? Actually, no. Before we do that, let's do one more. Just to, I want to nail this in there because these are easy points on the test, and I want to make sure you don't miss these easy points. All right. So let's do one more. Let's do one more. This one doesn't draw the curve for you, so you can either screenshot and paste the curve onto here or draw it by hand. I leave that choice up to you. I'm going to draw mine by hand because I'm trying to flex on how well I can draw this bell-shaped curve. Look how beautiful that curve is, right? Beautiful curve, beautiful curve. Look at that, isn't it? A little slanted. I just saw that right now. It's going up a little bit, but yes, thank you, Calvin. Fabulous. I appreciate your input. When you draw your bell-shaped curve, right, remember, what's the number that goes exactly in the middle? The number that goes exactly in the middle is your mean. I know that you're like, knock me, but median is supposed to be in the middle. But for these normal curves, the median, the mean, and the mode all share the same number, right? They all share the same number. I know that sounds kind of weird, but it's a strange thing, but it does happen. Okay, so let's see here. The mean value of the land and buildings per acre for the sample of farms is 2,400. So they're telling us the average is 2,400, right? All that is, all I'm doing is just reading that the mean value of the sample is 2,400 with a standard deviation of 450. So the standard deviation is 450. Between what two values do about 95% of the data lie? So 95%, remember, is 2 standard deviations above and 2 standard deviations below. That's what 95% is. And again, you don't have to memorize these percentages. Just get the chart somewhere on the side and just have that down so you can see that, oh, 95% is just all of these percentages added together. And then what would that be? This would be this value and this value to get 95%. But of course, we're not using those values for this problem. We're using 2,400 and 450. So we got to recalculate those numbers that go in the bottom. Okay, so what goes exactly in the middle is going to be my 2,400, right? And then I'm going to go 1 standard deviation above, 2 standard deviations above, and 3 standard deviations above. How do I get those values? Any ideas? Or better yet, did anyone do them yet and figure out what those numbers are for above the average? And then I need to do 1 standard deviation below, 2 standard deviations below, and 3 standard deviations below. Did anyone get those values yet? I'm kind of just being lazy and I don't want to type it into the calculator. I just want to see, did anyone get those numbers yet? And if not, that means you might have questions. And if you have questions, now would be the best time to ask, where am I getting these numbers from, right? Where the heck did you get 2,400 from, Knock Me? Where the heck what should I do to get these next numbers? Any ideas? Any clues? Or better yet, do you have answers? Do you have the numbers that go in the bottom? Are you going to make me do this by using the calculator? You guys not going to let me be lazy and just copy your answers? Come on, guys, let me get your answers. Come on. All right, Calvin, thank you. Calvin's going with the numbers above the standard deviation. We got 2,400. He's telling me that the next one is 2,850. The next one after that is 3,300. And the next one after that is 3,750, right? Calvin was kind enough to show us those values. But I'm going to write this down for you if you still are confused on how he got these numbers, okay? So check this out. 2,400 is just what the mean is, right? They tell us that value. And that mean goes in the middle every time. Carwin's got the other values on the other side, which is going to be 1950, 1,500, and 1050. Now, if you're confused as to how are these guys getting these numbers, right? Let me show you. To get this 2,850, you just take whatever number you have as your mean, which in this case is 2,400, and add 450 to it. That's it. That's all you got to do. You take the number that's in the middle and add 450 to it, right? This guy right here is just the mean, and then we just add the standard deviation to it. We do it again over here. This is going to be 2,400 plus 450, but we do the plus 450 You do it twice. That's all that is. That's how they're getting this number. They're adding the mean with the standard deviation a certain number of times. How do you know how many times you do it? Well, we say this is 1 standard deviation. We say this is 2 standard deviations, right? STD. Wait, Lewis was the one who laughed at that last time. He wrote down an STD. Anyways, 2 standard deviations away, right, would be this one right here. And that's how they got that value. They just took the mean and they added 2 standard deviations. And then for the last one, right, they're going to do it again. You take your take your mean of 2,400 and then add the standard deviation once, twice, man, knock me, just 450, and then a third time. And that's how you measure that it's 3 standard deviations away. 1 standard deviation away, 2 standard deviations away, and 3 standard deviations away. Are you guys okay? You guys see how they're getting these numbers? And if you go in the other direction, it's the same thing, except it's just going to be, instead of it adding to it, it's going to be the numbers subtracting to it. So it'll be 2,400, and this will be minus 450. And that's how we got those values there. Okay? Once you get those values, read the problem and see what it is they're asking for. If they're asking for a percentage, you need to go and look and see, well, where is 95%? How can I get 95%? And I can get 95% from going to the second standard deviation below and the second standard deviation above. That's how I get 95%. So I come back to this problem. Where's the second standard deviation below? That's this guy right here. That's the second standard deviation. Where's the second standard deviation above? That's right here. That's this guy right here. So the percentage from here to here should be 95%. But that's not my answer, right? They're not asking for 95%. They're asking for where does the 95% occur. And the where is going to be right here. It's going to be between 1,500 and 3,300. Between 1,500 and 3,300, and that's your answer in this case. That is your answer. So the last couple of them, the answers were percentages. This one, they gave you the percentage, and they're asking you to find the answer that it's between, right? And that's the one that then this is the part that's a little weird. You'll say, knock me, what if they asked me to do 34%? And I'm going to be like, well, yeah, that's a tough one because there's 2 34%. Would it be between here and here? Or would it be between here and here? And I'm just going to let you know right now, they're probably not going to ask you for a percentage that's that small because there's just too many ranges that you can select. So most of the times, when they ask you for the question that's like, hey, what is it? What is the value that is between? They'll usually ask you like these big numbers of 68%, 95, or 99.7. They rarely will ask you, hey, what's the values that are between that they are between to get like 13.5%? That's too tough because there's 2 of them. They won't ever do that. They usually do it for the bigger percentages for these types of problems, just to keep that in mind. I'm talking a lot, I realized. What I want to do, I wanted to poll you guys, if you guys could go into the polls, right? How do you feel about the normal curve, right? How do you feel about the empirical rule? That's the name of this section, I should say. The empirical rule. How do you feel about the empirical rule, right? Is this how should I get this on this poll? I should have thought this beforehand. Do you find this to be let's go with 1 if it's easy, right? 2, 3, 4, and then if you go with 5, we'll say that 5 is hard, right? You guys answer in the poll for me. Go into the activities button on the upper right hand corner if you guys could. The triangle, square, circle. Can you guys click on that and then go into the polls and then answer it? Is this easy? How do you feel about it? Does it feel easy, or does it feel hard, or are you somewhere in between? If you're at 3, you're kind of like neutral with this, right? Let me know. Can you guys answer the polls for me? Let me see what you guys think about this. Let me see what you guys think about this. And while you guys are doing that, I'll put this back on the screen so you guys can copy this. For those of you who still need to copy it, my fault for scrolling back and forth so much. But yes, please copy that down. And yeah, that's the big part of this is the empirical rule is the 68, 95, and 99.7. Okay, and if you want, we can do another example, right? One more example before we call it a day. Yeah, one more example. That'd be a good one. One person thinks it's hard. That's fair, and one person is going with a 4, so it's more than a little bit hard. Okay. A lot of you guys are saying that it is neutral, so you're saying that it's not too bad, but it's not too easy. And a couple of you guys are saying that it's easy. Okay, awesome. Let's do a couple problems then. Let's do a couple problems before we call it a day. So let's take a look here. Right? These are all example problems. You don't have to do them all for your notes. This is just extra practice if you want to do them for practice. Okay, so let's take a look here. Let's take a look here. So let's say I have, on a standardized test, Kathy's score had a score of 74, which is exactly 1 standard deviation below the mean. So again, you don't need to draw this out, but I like to, right? The mean is going to be in the middle, right? All the time. They tell us that Kathy has a score of 74, which is exactly 1 standard deviation below. So remember, when you do this, there's always going to be 3 standard deviations, 1, 2, 3 below, and 3 standard deviations, 1, 2, 3 above. But they're telling me that Kathy's score of 74 is exactly 1 standard deviation below, right? If the standard deviation for the test, S, is equal to 6, right? What is the mean for the test? So if you know one of the values and you know the standard deviations, you can fill out this whole chart, right? If you go towards the right, you're always going to add 6, or in this case, I shouldn't say 6. You're always going to add the standard deviation if you go towards the right. So 74 plus 6 would tell me that this one next to it should be 80, and the one after that should be 86, 92, right? And after that should be 98. How did I get that? I took this 6 and I just added to this number. I added 6 here, I added 6 here, I added 6 here, I added 6 here. That's how this works. If you know the standard deviation, you just add that number to the scores that you have, and it helps you fill this out if you want to go towards the right. If you want to go towards the left, we simply subtract 6, and you'll get the numbers to the left of it. So 74 minus 6 is going to give me 68. Yeah, 68, and then subtract 6 again. This will give me 62. I hope that's right. I think that's right. Now, do I care about all these numbers? No. But if I fill out these numbers on a test problem, like I said, I've got 4 out of 5 points right here. And all I did was took this number that they tell us was the score of Kathy. I put it into this location because they told me that it was exactly 1 standard deviation below. And that's where that is. 1 standard deviation below the mean is this location right here. With the standard deviation of 6, I was able to take that and add it to that score to get all of these numbers, and then subtract it to get all of these numbers. I don't even care about all these numbers, but again, if I'm just doing this for points, I get those numbers in there, I've got my points for this test problem. Now, the last part is, what is the mean score for the test? And remember, the mean is just the number that's exactly where? It's exactly in the middle of the curve. So that means that the mean for this problem is 80. It is 80. Are you guys okay? Does that somewhat okay or somewhat weird? Right? That's the whole part of this section of this bell-shaped curve, right? Getting those values in the bottom and then also playing with the percentages of those bottoms as well. Okay? All right. Let's see here. I think that's going to be it for chapter 2.4. There's more problems here. You can try them out. You can ask me about them if you have any questions about them. You can always feel free to ask. Most of you guys do stop by my office hours for retakes, but I've yet to see any of you guys stop by for homework. So I'm assuming you guys are getting these problems, but if not, you should figure that out soon before it gets too far down the line. So start working on these problems. I have them here, numbers 1 through 5 odd, 13, 14, 15, 17, 19 through 25 odd, and 29 through 39 odd. I already have these posted on your Canvas page. If you click onto it, it takes you into here. I'm sorry for those of you who are doing this using Google Docs. For the homework is PDF, so I don't have the Google Doc of that. So what you can do is, I don't know, since you're not doing it live, maybe just it doesn't save. So if you're still struggling with Kami, maybe do the write the answers on a Google Doc, and then when you submit, just submit the Google Doc at the end. Oh, we still haven't figured out how to do that, so we got to do that too. But yeah, so anyways, the homework is posted on here, right? And I have it listed in here as well as to what numbers you need to do. And yeah, I think we're gonna stop here. I know that I have in my notes or in my agenda that we're gonna start 2.5, but I think that's a little ridiculous because we only have like 8 minutes left in the class, and I'm gonna start a lesson in 8 minutes. So I think that's a good place to stop, right? We finished 2.4, huzzah, right? We did this whole thing with these standard deviations and whatnot. I really suggest you practice the homework or practice the remaining problems in your notes, because I have a really strong feeling that your quiz on Monday is probably going to take the numbers and the problems from your notes, because I feel like your teacher is feeling a little bit lazy today to make up problems. So he's probably just going to copy the problems that are there and put them in as a quiz. So just giving you a heads up, right? Your quiz on Monday. Yeah, your quiz on Monday. Or Tuesday, I should say. Quiz on Tuesday. I think on Monday we're doing something as a school as a whole. So I don't think you're going to have a quiz on Monday. So just a heads up. Your next 2.4 quiz, you will be doing something along these lines. And yes, Michael, you can submit the notes now. We are done with 2.4. Christina, we're going to have to figure out how we're going to get you to submit these notes, but you should have it saved in your drive, right? So we'll deal with that. Keep saying later. I got to go talk to someone in the tech place about it. All right. Anyways, guys, that's it for me. Thanks for listening. Thanks for stopping by. I really do appreciate you guys, especially those of you who are typing in the chat. And if you are still a little too shy, you know, I appreciate you being here, right? It makes it, you know, a lot more fun than just me talking to a screen, right? So please note that I do appreciate you showing up in here, and I do appreciate you when you guys are typing into the chat. It makes my day. It makes this a little bit easier to deal with. But yeah, guys, that's it for me for 2.4. Please submit those notes. Get started on the homework. Get ready for a quiz for 2.4 next week. And with that, I won't see you guys until after the weekend. So please have a good weekend. Have a good Halloween. Stay safe. Stay out of trouble. Don't go to jail, right? And don't get pregnant. I'll see you guys later. All right? So long.